we're covering IR. IR stands for infrared. It's a really low cost and easy to implement technique to transmit data wireless in a low range. And it's used mostly in remotes, like TV remotes, those remotes that you get when you buy one of those RGB LEDs. Also, some mini split AC units work with these type of remotes where you can change the temperature or the way that the fan works and all that. And I've seen this type of technique also in those really low cost wireless remotes that you can get on eBay or AliExpress, that you press a button and then you have to wait like half a second for the video game to react. So it's low cost, it's really simple, and for low range, and when speed's not really something that matters, you can use it. How it works? Well, the transmitter is done with an infrared light emitting diode, also known as LED. So the fact that it's infrared means that we cannot see it. It's below our visible light spectrum. That means that if you turn on one of these clear LEDs, you may think that they're not working because they're not emitting any type of light. But the thing is that we cannot see it. It's actually emitting light. And on the receiver side, we have an infrared phototransistor, which is a transistor. Think about it like a switch that will close the circuit when it detects infrared light. Here we have an example. We have a infrared LED on the left side and the push button is not pressed. Then we have this phototransistor that's connected to 5 volts, but since there is no light, this side of the transistor is not connected to this one because there is no light detected. When it detects light, these 5 volts will go down here. And now we're going to be able to do a digital read using an Arduino to detect a 1. So right now we're detecting a 0 because since there is no light here, or infrared light, the phototransistor is not catching anything and it's not being able to close to get these 5 volts here below. Once we press the button, the infrared LED will emit infrared light. In this case, it's just an animation. In real life, we won't be able to see it. But that light will heat the phototransistor and it will bring those 5 volts here below. And now we're going to be able to read a 1. So when there's no light, it's a 0. When there's a 1, that means that there's light in the infrared LED being detected by the phototransistor. So that's how remotes work. They have this light that sends 1s and 0s at a frequency usually of 32 kilohertz. Those 1s and 0s are captured by your Arduino and they represent a code. Pretty simple. There's nothing real hard here or complicated. The way that we code it, since most of the messages are 32 bits or 16 sometimes, depending on the code, is making packages of 4 bits. So those 4 bits are usually written with a 0x, which is for hexadecimal, and every digit in hexadecimal represents 4 digits in binary. So as you can see here on the table on the right, for instance, if you see F12B, that F in the table represents 4 1s. A 1 represents 0001, and then A2 is 0010, and B is 1011. So it's just another way to visualize data. If you see a 0x written, that means that it's hexadecimal. So don't be afraid if you see any letters like A, B, C, D, E, F. If there's a 0x, it's just a way to shorter your data. I mean, everyone prefers to write just 4 digits instead of 16. And that's basically how it works. Remember, we need to include the Arduino remote zip library. We're going to see how to include that in the Lab 5 example, in your Lab 5 example too. But for the lecture, that's all that we need to understand to move on to the lab example codes.